Good morning, everyone. Today we're going to start the second half of this unit. I don't want to say it's a half because there's only a couple lessons to it. But the second part of this unit, I guess, would be the better wording. And the second part is actually on combinations. So we've spent a number of days dealing with permutations, arranging objects in a certain order. And now we're going to spend a couple days on combinations. So let's start out with an intro example to highlight the difference between the two. And there's one main difference, and we'll highlight that through this example. So let's take a look at this scenario number 1. From a group of 10 students, you need to choose a president, vice president, and secretary. So this is very much a classic permutation scenario. It's a classic permutation scenario where you have 10 people on a club and there are 3 positions of authority. And the 3 positions of authority are president, vice president, and secretary. And all 10 people are interested in the positions because obviously they want to put it on their resume. So as the group leader, I can't choose. So I put their names in a bowl and a bag, and I decide that I'm randomly going to pick them out. So for the position of president, obviously you're going to choose president first, so order becomes very important. You have 10 choices. For the position of vice president, you have 9 because somebody's already been chosen pres. And for the position of secretary, you have 8 choices because somebody's been chosen as president, somebody's been chosen as vice president, and somebody's now being chosen as secretary. So there are 720 different ways that this can happen. So let's take just a look and kind of review over things. Your N is 10, and your 10 represents the number of objects, number of people. Your R is 3, and that represents the number of objects arranged. So if you have a permutation, the formula of n choose r is n factorial over n minus r factorial. That's our classic permutation formula. So in this case, it would be a permutation of 10 choose 3, 10 factorial over 10 minus 3 factorial, 10 factorial over 7 factorial. Now we could write this out in long form, or we could use our calculator, and we'll end up with an answer of 720. What we also discovered in the permutation unit is that you have on your calculator an NPR button. And that NPR button will do all of this work as well. So, visual technique, formula technique, calculator technique, 10, permutation, choose 3. And if you type that into your calculator, let me just show you on mine. 10, second function, permutation. My permutation button is over the multiplication. Choose 3. 720. So 3 different ways to attack the same question, this being a permutation question, because when you're picking positions of authority, there's some prestige, obviously, to president, vice president, and secretary. When you're picking positions of authority, there's definitely an order. Okay, actually, let's highlight that. Scenario 2. From a group of 10 students, you need to choose 3 students to clean up after the dance. Now, notice the similarities. 10, choosing 3. But now let's point out the differences. In the first example, president, vice president, and secretary obviously have some worthiness to put on a resume. There's some prestige. They're kind of exciting. 3 students to clean up after the dance, I don't think I would have a lineup to do that. I don't know if all 10 students are going to be like, yes, sign me up to do that. So the difference in the question is very, very slight. And what it's telling you is that I don't care who the 3 students are. I just need any 3 students. And order is not important. Notice that it's not saying that in the question, though. You have to kind of decipher whether order is important in the question. Okay, so hold on. Let's think about this. In a classic permutation question, you would have 10 times 9 times 8. Okay? But within that question, you have to take out the objects not being considered. So, objects not considered. Total objects. And that would get us our beautiful 720. But what is considered in this formula, notice it's the exact same formula that we got up here. What's considered in this formula and what's still being factored into this formula is order. And because of that, because order's being factored in, there are too many options still in the answer of 720. So we need to remove order from the 720. We've looked at all the kids. We've taken out the 7 that aren't going to be helping out at the dance. Now somehow, some way, we've got to take out order. And the way that we're going to do this is we're going to factor it out. We're going to divide it out. We're going to pull out the ordering of the 3 people. The ordering of the 3 people that are going to stay and help out at the dance. So by dividing out the ordering of the 3 people, we're removing order from the question. Okay, so let's look at this one more time. We looked at all 10 people. We removed the 7 people that are not going to be staying and helping out. And because helping out at the dance is not some prestigious, cool, something that you're going to put on your resume type of job, this is a combination. We're going to remove the ordering from the question. And to remove the ordering from the question, you're going to divide out that 3 factorial, the ordering of the 3 people that are staying to help out. So hold on, let's take a look at this. 10 factorial, 10 minus 3 is 7 factorial, almost identical to the permutation, divided by 3 factorial. Let's try that on our calculator. 10 factorial divided by, and I'm going to put it in brackets, 7 factorial times 3 factorial, close brackets. So 10 factorial divided by 7 factorial times 3 factorial, answer of 121. This seems a lot better. Notice 720 options because order is still important, versus 120 options because now order has been removed from the situation. So let's take a look. It says, this is different than a permutation because in this case, order does not matter. I'm arranging 3 students in any particular way. I just need 3 of them. I'm not arranging 3 students in any particular way. Sorry, I said that wrong. I'm not arranging them in any particular order. President, then vice president, then secretary. I'm just needing 3 students to help me out. This is a combination. Now, what's different about a combination, and I hope we've discovered that, is that order is not important. And in a combination, a selection of R objects from N objects without regard to the order. So you're still having 10 total objects. You're still arranging a certain number of objects. You're just removing the order. So what's going to be critical on your behalf is, how the heck do I figure out whether the question's asking me to order or not order? And in our first scenario, that idea of a position or something of prestige is kind of a way to recognize. Notice there's more prestige to being considered pres, vice pres, and secretary versus being chosen to help out at a dance. Okay, how about we flip? And we're going to look at 4 little scenarios right at the very beginning and just kind of see whether you think they are a perm or a com. Okay? We're going to read each sentence one at a time, and I want you in your own mind to decide whether you think it's a permutation or a combination. You are choosing 2 people to play the leads in the school play. Perm or com. This is a permutation. Again, positions of authority. You are choosing, or positions of prestige. You are choosing 2 people to do the lighting in the school play. Combination. Okay? Microwave dinners are on sale at the supermarket, and a person wants to buy 4 different ones from a selection of 7. Doesn't say what type, doesn't say any sort of detail, just go to the grocery store and buy any 4 frozen dinners. Combination. Notice there's not any specific detailed instructions. The person who buys the dinners, or who bought the dinners, has to serve them to their 4 family members. So think about me coming home with 4 different frozen dinners, and there's 4 of us here at the Martel household. Obviously my youngest son, who's my picky eater, is going to scour them and get his choice first. So order becomes important. Okay. Now, before we get into our examples, let's just recall the permutation formula, which we have memorized. And we know that the permutation formula was sort of used in our combination question. And we tweaked it a bit. By dividing out the ordering of the objects. So here we go. We've got our beautiful combination formula. And that combination formula is now n factorial over n minus r factorial, r factorial. So all we did was technically tweak the combination formula so that we can do a combination. So let's just take a look at it again. 10 factorial, choose 3 factorial. That was our example. Left us with 10 factorial over 10 minus 3 factorial. Left us with 10 factorial over 7 factorial. In the combination formula, it was 10 factorial over 10 minus 3 factorial over 3 factorial, which left us with 10 factorial over 7 factorial, 3 factorial. Now, the interesting thing about a combination is that a combination can be written in a couple of ways. Let's take a look. A combination can be written as combination 10 choose 3. A combination can be written 10 combination choose 3. And a combination, careful with this one, can be written as bracket 10 choose 3. Notice this is not a fraction. There is no division line in there. Okay? Please make sure that you don't write the division line in there. That's a huge mathematical BF. This is 10 choose 3 in brackets. Notice the difference. This is not this. This is a no, 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 no. Okay? All three of these formats represent the exact same meaning, combination. Now, a permutation can only be written in two ways. Permutation of 10 choose 3, 10 permutation choose 3. The only difference is this one right here with the combination, and we're going to use it a lot, so be super duper careful. Okay, let's jump into some examples. I think you'll get some clarity once we do some examples. I need to choose 5 students to help out at a swimming meet. How many ways can I choose a group of 5? Okay, let's talk just about the first part of the question. I need to choose 5 students out of 7 to help out at a swimming meet. Now, obviously, again, this is not something that you're going to put on a resume. There's no sort of prestige. You're doing a great deed and you're helping me out. This is a combination. There's no ordering to this. So let's take a look. How could this be written? This could be written as a combination of 7 choose 5. It could also be written as 7 combination choose 5. Or it could also be written as 7 choose 5. All 3 of those techniques are acceptable. You don't have to write all of them. Any one will do, but all 3 are acceptable. Now, the formula is n factorial, which is our 7, n minus r factorial, so n being our 7, r being our 5, and again, removing that ordering of the 5 people that are helping out, factoring out, pulling out, taking out that ordering of the 5 people. So hold on, I've got 7 factorial over 2 factorial, 5 factorial. And when I look at that, remember, if we go back to factorials, 7 factorial over 5 factorial is 7 times 6. 2 factorial, 2 over 1, 42 divided by 2, answer of 21. And again, this can be put straight in the calculator. Check this out. 7 NCR, notice my NCR button is right beside the NPR. Choose 5. 21. So we have a factorial button, an NPR button, and an NCR button. Okay. Let's check out just playing around with the calculator. Okay? 7 NCR 5. Let's check out again the calculator. 13 NCR 8. Now, just so that we understand, this could also be seen as n factorial, n minus r factorial, r factorial. 13 factorial over 5 factorial, 8 factorial. Now watch that on the calculator. 13 factorial divided by 5 factorial times 8 factorial, close bracket. Let's take a look at our next example. And I'm choosing this one because it's quite important. Notice what's being discussed here. What's happening is we're seeing a combination of 6 choose 4, and then another combination of 4 choose 1. In between these two combinations is a beautiful multiplication. Very similar if I said to you 6 over 4 times 4 over 1. The assumption is combination of 6 choose 4 times combination of 4 choose 1. Let's take a look at that on our calculator. 6 choose 4 combination, 4 choose 1 combination, multiply 15 and 4, answer of 60. So these little examples at the bottom, they're just getting us used to our formula. They're just getting us used to using our calculator. Okay. Let's head into some more examples. Sheldon the shopper needs to buy 12 ties. There are 15 left in the store. How many ways can he choose 12 ties? Let's take a look at the wording. I send Mr. Martel into a store. He needs 12 ties. I said, just buy anything. I'm not giving him any clear instructions. I'm not saying, geez, get a striped tie, get a paisley tie, get a polka dot tie. I'm not telling him get a blue tie, get something, that'll match your school colors. I'm giving no detail, no definition. When no detail or no definition is given, this is a combination of 15, being my N, choose 12. Again, it can be written like this. Again, it can be written like this. You don't have to write all 3 ways down. I just want you to understand that it can be written 3 ways. The formula would state 15 factorial over 15 minus 12 factorial, 12 factorial. 15 factorial over 3 factorial, 12 factorial. Remember, 15 representing the total number of objects, 3 representing the 3 ties left in the store, 12 representing the removal of the order. The removal of the order of the 12 ties. He's just going in, he's taking 12 ties, throwing them in a bag and saying, here's what I want to buy. Okay? Let's look at another one. Gardener Gus buys 3 geraniums, 4 shrubs, and 8 rose bushes. The nursery had a choice of 10 geraniums, 6 shrubs, and 10 rose bushes. How many different ways can Gus choose his plants? Again, notice in the wording of this question that I'm not giving, or you're not being given, any sort of detail. It's very, very broad. Go into the nursery. There's 10 geraniums on the table. Pick 3. Go into the nursery. There's 6 shrubs in the courtyard. Pick 4. Go into the nursery, there's 10 rose bushes, pick 8. So let's take a look at geraniums. This is a combination of 10 choose 3. Let's take a look at shrubs. This is a combination of 6 choose 4. Let's take a look at rose bushes. This is a combination of 10 choose 8. So Gus is going in, he's buying 3 of the 10 geraniums, no order, just he's in a rush, he's just quickly picking them up. 4 of the 6 shrubs and 8 of the 10 rose bushes. Let's do this on our calculator. 10, choose 3. Oops, sorry. 120. 6, choose 4. 15, 10, choose 8. Now, my question to you, and if we were in class, this is what I'd be saying. What do I do with those 3 numbers? Do I add them or do I multiply them? Now, think about the wording of what what adding and multiplying presume. Adding presumes or. So, is Gus being instructed to buy geraniums or shrubs or rose bushes? And presumes multiplication. Is Gus being told to go to the nursery, buy geraniums and shrubs and rose bushes? Is he leaving with all 3 different types of plants? Yes, he is. This is an and question. This is a multiplication. He wasn't instructed to go to the nursery and just come home with geraniums or shrubs or rose bushes. He was told, go there and get all 3 types of plants. Okay. Next example. I want a big star beside it. This is the classic combination type of example. Very, very classic. Okay, let's take a look at it. A data management club consists of 6 students and 2 teachers. So 6 students, 4 boys and 2 girls, 2 teachers, me and Miss Staples. How many teams of 4 can be created? Now, if you look back on the previous page, give me 1 second, I'm going to flip. You notice that I highlighted the word group and it's underlined, but I didn't really talk about it. Now all of a sudden, I'm highlighting the word team as well. There are certain words in questions that indicate a combination. Now, so far, the way we've been indicating a combination is non-detail, non-positions of authority. So that vice president, president question versus just helping out. But there are other words and other ways that you can define a combination question. One of them is group, when you're making a group of people. The other one is team. Another one is committee. Another one is card hand, like a 5 card hand, an 8 card hand. And the final one is batch, like a batch of cookies. Okay? Those particular words are, in most cases, strong indicators of a combination question. So that'll help you too when I start mixing up the questions. Okay, let's go back. So we right away know that this is a combo because we're looking at teams of 4. Now, let me give you the scenario. We have a data management club, 6 kids, 4 boys and 2 girls, me and Miss Staples. We get an invitation from the University of Waterloo to go to a conference at Waterloo dealing with stats. And the invitation invites 4 people from Notre Dame to go to this particular conference. And it's pretty exciting, it's pretty prestigious. So we go to our principal, Mr. Gripsma, and we say to him, listen, we've got this fantastic opportunity. You know, we have this beautiful club. There's 6 kids. There's 2 teachers. We really want to go to this thing. 4 people can go. he says, that sounds fantastic. That sounds absolutely fantastic. And you know what? I don't care who goes. Anybody can go. I'm not going to put any restrictions on it. Anybody can go. So, whoa, anybody can go. Well, that means that this is a combination of 8 choose 4, because there are 8 total people, 6 kids and 2 teachers, and the group size that is being invited is 4. 4 students, or 4 people can actually go of the 8. So this is a beautiful combination of 8 choose 4. Any of us can go. And 8 choose 4 is 70. Let's go to Mr. Gripsma with a different scenario. We go to him, we tell him about the conference. He says, this is fantastic. But you know what, ladies? I'm just going to ask, the team that you send, you should let the kids have this opportunity. Just kids. Only students. Let them go. They're all good kids. I trust them completely. So instead of being a combination of 8 choose 4, actually, if we're looking at students, out of the 6 students, 4 of them get to go, and out of the 2 teachers, none of us get to go. Interesting. Take a look, because the top number still adds to the total, and the bottom number still adds to the group size. Just like we had in part A. So 6 choose 4 times 2 choose 0 is 15 times 1, answer of 15. Let's keep going. We go to Mr. Gripsma again. He says, I'm totally in favor of you guys going to the conference, but you gotta have a teacher. There's gotta be one teacher. One of you have to go. Well, if that's the case, there's 2 of us, and one of us has to go. Then that being said, how many students, if the group size is 4, how many students by default will then be able to go? And out of the students, out of the 6 students, 3 get to go. Notice again, total, group size. So 2 choose 1 is 2, 6 choose 3 is 20, answer is 40. Go to Mr. Gripsma again, and he says, yeah, I love the idea, but I want to make it, fair. I want 2 females to go, and 2 males. 2 boys and 2 girls. 2 females and 2 males. Okay. Well, in our previous examples, we divided everything, or we separated the people into students and teachers. Now, because he's putting restrictions, not in terms of students and teachers, but in terms of males and females, or boys and girls, that's how we're going to subdivide. Well, how many boys were there? 4. And how many girls were there? There were 2 girl students and 2 female students. So again, my total always adds up to the total of 8. And my group size, he said, 2 boys and 2 girls. So 4 choose 2 is 6. 4 choose 2 is 6. 36. Again, notice I'm subdividing in B and C based on teachers versus students, and I'm subdividing in D, I'm subdividing based on boys and girls or males and females. Okay, let's take a look at the next one. Miss Staples must be on the team. So we go to Mr. Gripsma and he says, we sit down with him and Miss Staples says, listen, I would really like to go to this conference. It's my alma mater. I want to go there. I'm going to know some of the teachers. I want to be there. So if Miss Staples wants to go, now we're subdividing not in terms of students and teachers, but we're subdividing in terms of Staples and others. Staples and others. So Mr. Gripsman doesn't care who else goes. Doesn't care who else goes, but Staples definitely has to go. She wants to go. She's requesting it. So that means now that the group size from the others is going to be 3 because Staples is already going. And the others, again, have to add up to that total of 8. 8 and 4. 1 choose 1 is 1. 7 choose 3 is 35. So notice this whole idea of how the question is subdivided is really, really important. Really, really important. Okay, let's keep going with this question. There must be at least one teacher on the team. So Mr. Gripsma says, as long as at least one of you go. Now, let's talk about the word at least. We know from our permutation that at least means one teacher or 2 teachers. So there's 2 scenarios to this. There's the one teacher scenario or the 2 teacher scenario. So again, we're subdividing in terms of teachers and students in this particular question. Teachers and students. So if one teacher goes, it's a 2 choose 1. Top number has to add up to 8. Bottom number has to add up to 4. If 2 teachers go, it's a 2 choose 2. 2 people to choose from, all 2 go. Top number has to add up to 8. Bottom number has to add up to 4. So 2 choose 1 times 6 choose 3 is 2 times 20, or 40. 2 choose 2 times 6 choose 2 is 1 times 15. 40 plus 15, 55 ways. Excellent. There must be no more than one boy. So Mr. Gripsma says, yep, absolutely, you guys can go on the field or go to Waterloo to the conference. But you know what? I don't want anything more than one boy going. For whatever reason, that's what he says. So no more than one boy, we can look at this question in 2 ways. That could mean 0 boys or 1 boy. No more than one boy could mean that 0 boys are going or 1 boy is going. So now this question is being subdivided again in terms of boys and girls. Don't forget, me and Miss Staples are considered girls here. How many boys were there? 4. If 0 are going, top number has to add to 8. Bottom number has to add to 4. So if no boys are going, that means the 2 female students and the 2 female teachers are going by default. How many boys were there? 4. If 1 goes, top numbers have to add to 8, bottom number has to add to 3. If 1 boy ends up going, that means 3 girls. I don't know who the girls are. It could be students, it could be teachers, it doesn't matter. Just any 3 girls are going. 4 choose 0 is 1. 4 choose 4 is 1. 4 choose 1 is 4. 4 choose 3 is 4. 1 plus 16 gives me a beautiful answer of 17. Now, what I want to show you is sometimes there's multiple ways of doing a question. You're familiar with the idea of reverse psych. From permutations. And reverse psych says no restrictions minus what's opposite to the question. So what's opposite to 0 and 1 boy? 2 boys, 3 boys, and 4 boys. That's all considered opposite. If the question is saying no more than 1 boy, 2 boys is opposite. 3 boys is opposite. 4 boys is opposite. So we're going to subtract all of those options from our no restrictions. Okay, well, hold on. Let's think about this. No restrictions was 8 choose 4. Big square bracket, because I'm going to have to do a lot of work in here. 2 boys would be 4 choose 2, 4 choose 2. 2 boys and 2 girls. 3 boys would be 4 choose 3, 4 choose 1. 3 boys, 1 girl. 4 boys would be 4 choose 4, 4 choose 0. 4 boys and no girls. Now, I know you're looking at this reverse technique and you're saying, geez, Ms. Martel, why the heck would I choose that way? It's longer, it's more cumbersome, there's more calculations. I agree in this question. I agree wholeheartedly. But sometimes there will be the circumstance where it won't be as much work. Sorry, guys. I need to get my calculations going. So 8 choose 4 is 70. 4 choose 2 and 4 choose 2, that's 36. 6 times 6. 4 choose 3 and 4 choose 1, that's 16. 4 times 4. And 4 choose 4 and 4 choose 0, that's 1 times 1. So 70 minus 36, 16, and 1. 70 minus 53, same answer of 17. Classic, classic, classic combination question. Team question. Okay, I'm going to stop the video here because it's getting long, and I'm going to create our next video.